Now, there's a couple different kinds of chemical formulas. There's a formula that would look like this. This is called a structural formula. It actually shows you the structure of the compound. Okay? You've got two hydrogens attached to an oxygen. It shows you what it looks like. There is also something called a molecular formula. And a molecular formula is going to tell us the exact amount of atoms of each element in the formula. For example, glucose. Glucose has the formula C6H12O6. This means there are 6 carbons, there are 12 hydrogens, and there are 6 oxygens in that formula. It's a discrete unit. So the molecule for glucose has 6 carbons, 12 hydrogens, and 6 oxygens. Okay, that's the second type of formula. The third type of formula, and there are more than even these that I'm giving you right now, is called an empirical formula. An empirical formula shows the lowest whole number ratio of atoms in the compound. Okay, so again, let's take glucose. Glucose's molecular formula. You guys okay out there? So far, so good? Was C6H12O6. Its empirical formula is going to be CH2O. Okay? Now, how did I get that? These numbers, 6, 12, and 6, are a molar ratio. It takes 6 moles of carbon atoms. Remember, a mole is a group. And 12 moles of hydrogen atoms and 6 moles of oxygen atoms, or I could say it 6 groups of carbon and 12 groups of hydrogen and 6 groups of oxygen to make one group of glucose. Well, the empirical formula says I have a ratio of 1 to 2 to 1. It does not tell me how many I have. So 6 to 12 to 6 in math, the largest common factor, right, is 6. 6 divided by 6 is 1. 12 divided by 6 is 2. 6 divided by 6 is 1. So the molecular formula for glucose is C6H12O6. The empirical formula for glucose is CH2O. You see the difference between molecular and empirical? All right, let me show you another example. Okay? All right, good. Let's say we have CH4. Okay? Is this compound, this is methane. Okay? This compound right here has a ratio of 1 to 4. Empirical or molecular? Is it the lowest whole number ratio, 1 to 4? Can I reduce it any further? You can? You can reduce that? No, you can't reduce that anymore. So 1 to 4 is an empirical formula. This is empirical. Okay. If I multiply everything in that formula by 2, we get C2H8. Is that empirical? No, this one would be molecular. C3H12. Empirical or molecular? Molecular. C4H16. Molecular. Okay? So every compound has how many empiricals? 1. That's the lowest one. That's the empirical one. And molecular formulas, and this is important, so listen real closely. The molecular formula is any multiple of the empirical. Now, this empirical formula right here can also be classified as a molecular formula because methane's molecular formula would be C1H4. It is a multiple of the empirical. It's only times 1. Okay, so let's say I have CH4, and then times 2 would be C2H8, C3H12, C4H16. These are multiples of this guy right here, which is up times 1. This one is both molecular and empirical. These are only molecular. Every compound is going to have one empirical, that's the first one, and all the others are going to be molecular, including that first one, because that's the times 1. Do you understand? C5H10. Empirical or molecular? Molecular. What is its empirical formula? CH2. CH2 is the empirical formula of this guy. Can you give me another compound, another molecular formula that has the same CH2 empirical formula? Say it louder. C10H20. C what? C2H4. C3H6. C9H18. These are all molecular formulas based on this empirical formula. The empirical formula is just the first one. Easy peasy lemon squeezy? Any questions on empirical versus molecular formula? Very easy. Okay, now we're going to talk about something called percent composition by mass. Oh, actually, before I do that, let's do this. Okay, I'll take the CH2 again. Okay, what's the gram formula mass of CH2? This is a good review. Gram formula mass. 14. Okay, carbon, there's one of them. It weighs 12. Hydrogen, there's 2 of them. They weigh 1 apiece. 12 times 1 is 12. 2 times 1 is 2. So we get 14 grams per mole. Let's say we have an empirical formula of C3H6. This is the molecular formula based on this empirical. Ladies, put the phones away. Okay. What's the gram formula mass going to be of C3H6? What is it? 42. How'd you do that so fast? How many times bigger is this than this? 3 times bigger. So if this is 3 times bigger than this, then the molar mass is also going to be 3 times bigger, correct? So 14 times 3 is going to give you 42. Happy New Year. Good, how are you? You good? You understand? It's not that hard, right? Okay. All right. Percent composition by mass. Take your reference tables over and flip them over to the back page. We got a formula we're going to write down. Okay. Percent composition is equal to the part of whatever you want the percent of divided by the whole thing times 100. Do you see that formula on the back of your reference tables? Or is it too dark in here? You can see it?
Yeah.
Okay. Let's say we want to find the percent of hydrogen in H2O. How much of one group of water is going to be hydrogen? Okay. So we're going to find the gram formula mass of water, which we know is 18, right? But let's just do it out so you have all the numbers where you need them. Hydrogen, there's 2 of them. They weigh 1 apiece. Oxygen, there's 1 of them. It weighs 16. So the whole thing weighs 18 grams per mole. 18 grams per mole. That's what I wrote here. If I want to know the part that is hydrogen, how much did the hydrogen weigh in this whole Megillah? 2. And the whole thing weighed 18. So to find the percent, we're going to do percent is part over whole, P over W, times 100. Ooh. 2 for the hydrogen. That's the part that was hydrogen. You following? Over the whole thing, which was 18 times 100. 11.1% hydrogen. Somebody check my math. I'm going by memory here. You have a calculator? You need one. Is 11.1 or 11 point something? Okay. Okay. Everybody good with how I found? All right, let's find, this is the percent that's hydrogen. Give me the percent that's oxygen. Let's do it out. Okay. So the percent is going to equal part over whole times 100. The part that was oxygen is going to be 16 divided by, what's the whole thing weigh? 18 times 100. The percent is going to be 88.9% oxygen. Now, some of you already saw that if we're doing percents, these needed to add to 100% because the whole thing should be 100%. So what some of us did was we just took the 100 minus the 11.1 and we got 88.9. But I wanted you to see that it will work for anything, this formula. Okay, you good? Okay, let's find the percent. Give me the percent of sulfur in H2SO4. Let's do the percent of sulfur in sulfuric, this is sulfuric acid. Sulfuric acid. Okay. Okay, so hydrogen. There's 2 of them. They weigh 1 apiece. Sulfur, there's 1 of them. It weighs 16. And oxygen, there's 4 of them. It weighs, I lied. 32, thank you. 32, and oxygen is the 16. My brain was way ahead of my hand. All right. 32, and 4 times 16, 64? I'm going to go with 64. 4, 5, 6, 7, 8, 6, 7, 8, 9. 98 grams per mole. So this is my whole. That's what my whole thing weighs. The entire H2SO4 weighs 98 grams per mole. We worked on that before the break. Then we want to say, how much does the sulfur weigh out of the whole thing? So the sulfur is going to be, the percent of sulfur is going to be the part that's sulfur. I put PS so that I remember it's part of sulfur divided by the whole thing times 100. 32 divided by 98 times 100. That's going to be the percent sulfur. 32 point something percent? That's about right. 32.7% sulfur. It's easy, right? Easy peasy lemon squeezy. Okay. Let's take a look at this formula. Okay, it's not like something you've seen before.
Oh, no.
No, it's not that hard. It's not hard. Okay? Let me explain to you what this is. Do I have time? Yeah, I have 8 minutes. Okay? This, do you know what this is called? What's the name of it? What's the Cu? Copper sulfate. What copper sulfate? Copper 2 sulfate, okay? Because this sulfate has a -2 charge. Don't forget all the good stuff we learned before break. And this was a +2 here. Okay, so this is copper 2 sulfate. Now, in chemistry, this little dot does not mean multiply. What that little dot means is attached. Okay, so if you envision it like this, you've got a copper 2 sulfate. There it is, in a nice pretty cloud. It's actually not a pretty cloud, it's an ugly cloud, but I'm going to try again. My hand's not warmed up. Okay. And attached to that copper 2 sulfate, I have 5 groups of water. Focus. You got 7 minutes. Okay. So let's say I have a group of water that looks like this, and a group of water that looks like this, and a group of water over here, and a group of water over here, and a group of water over here. So what this is telling us, it's telling us I have a copper 2 sulfate attached to 5 moles, 5 groups of water. And there are my 5 groups. 1, 2, 3, 4, 5. And they are attached.
Yes.
Okay? You do not multiply them. If you are asked to find how much the gram formula mass of all this is, what do you do with them? How could I find out how much this thing weighs? You add them all up. You do not multiply. No, no, no. So let's figure out how much the copper 2 sulfate with 5 waters attached to it weighs. I'm going to get another piece of paper. All right, so CuSO4 with 5 H2Os attached. Let's figure out how much the copper 2 sulfate weighs. Copper, there's one of them, it weighs 64. Sulfur, there's one of them, Ange told me it weighs 32. Oxygen, there's 4 of them, they weigh 16, that's going to be another 64. Okay, 4 times 16 is 64. Add this whole Megillah up. This copper 2 sulfate weighs 160 grams. Got it? Okay. So this part right here, this, I'm going to color it in because it makes me happy. This green part weighs 160 grams. What does 1 water weigh? 18 grams. Okay, now you could figure it out. You could say H, there's 2 of them, and 1 and 2, and oxygen is 1 of them, times 16 is 16, and there's 18 grams per mole. However, how many waters do I have here? 5 waters. So 5 times 18 is going to equal 90. Check my math. Good, all right? So all of these guys, which I have in red, pink, I picked red here, but all of these guys, each one of them weighs 18. 18 plus 18 plus 18 plus 18 plus 18 gives me 90. So the whole Megillah is going to weigh 250 grams. Pretty heavy.
Yeah.
Okay? Does everybody understand what just happened?
Yeah.
Okay. If I want the percent of water in the CuSO4 5 H2Os, how would I figure that out? Go ahead.
90 divided by 160.
Not by 160.
250.
Right, because I want it out of the whole thing. And this sucker, right down here, I'll make it green, that's what the whole thing weighs. And the part that is water weighed 90. So let's do percent of water equals the part that was water, PH2O, part water, over the whole thing times 100. We know that the part that was water was 90 grams. The whole thing weighed 250 grams times 100. So the percent that was water is 36% water. Okay? No, 36 is fine. Okay? This thing right here is called a hydrate. It's a hydrate. Mia, got this? It is a hydrate because it has water attached to it. Anytime you have a salt, and this copper 2 sulfate is a salt, with water attached to it, it is called a hydrate. Now, let's see how we name this hydrate, just for fun. Okay? Copper 2 sulfate. Copper 2 sulfate. What is 5? What's the prefix for 5? Pent. Pentahydrate. Copper 2 sulfate with 5 waters, hydrates attached to it. Copper 2 sulfate pentahydrate. All right, let's stop there today. We'll finish up tomorrow. Why is this not stopping?